I'm going to build this classic Lego Technic Dune Buggy at nearly 10.5 times normal scale. Big enough for me to drive. Could this be the project that breaks me? Following those instructions. I shouldn't be following those instructions. Come on, think! I'm not thinking. That's a suspension strut. Hey, I just swallowed a fly. What's going on in my mind? People are going to be shouting, "It's on the floor!" Yes, I've built giant scale Lego inspired models in the past, and 2 of them are drivable. There's the go-kart that does 30 miles an hour, and the monkey bike with working suspension.
That is way more fun than it should be, dude.
But at nearly 10.5 times normal scale, this project is going to be a real challenge. The largest I've gone to before is 8.3 times larger, which was the monkey bike and the go-kart. I keep saying nearly 10.5 times scale, and that's because the actual scale is 10.42. The reason being that the axles scale up to 50 millimeters, and I can use 50 millimeter bearings in these Technic bricks. It's not a huge jump between 8.3 and 10.4 in scale. It's actually only about 25%. However, the volume is cubed, so this part at 10.4 uses twice the material as this part at 8.3. That means it's going to weigh twice as much and take twice as long to print. At 10.4 times scale, this kit would have over a 1,100 times volume increase. It's ridiculous. So at 200 grams, this would come out at 225 kilos. Of course, I'm not going to print it solid. I'll try and keep it as light as possible, but retain the strength. It is going to be a real challenge. Let's take a closer look at some of the features on this model. Although this is a fairly simple Lego model, I think it looks very cool. The parallel rack and pinion steering is fairly basic, but it did have a very tight turning circle. This is a 2-seater design, which I'm going to convert to a single seat placed behind these 2 seats in the cargo bay. To get in and out, I'm going to make the roll cage flip forward by removing the rear 2 retainer pins. My head and shoulders will be poking through the roll cage. I'll also modify the model so the steering wheel is located in the centre. The steering rack also has a lot of play in it due to the pinion axle only being supported in the middle, but I think I have a solution to that I'll explain later. There's this funky independent swing arm suspension. Although this seems like a pretty cool setup, it's going to be a bit of a nightmare when turning, as the body of the vehicle will want to lean away from the corner. The effect of this is to lift the inside front wheel off the ground, which is going to make a very interesting driving experience. I think these rear swing arms are going to be a real problem. There's so much leverage between the wheel and the swing arm, it's going to produce a lot of torsion and twist the 1x8 beam. I can strengthen this assembly, but it may be that I have to join the 2 swing arms together to form a single piece like this. This will prevent them from twisting, but of course lose the independent suspension. So I'll start with the independent axles as per this model, but I think it will be necessary to replace the rear axle with a single rigid axle that joins the swing arms together. To make this a functional drivable vehicle big enough for me to sit in, I'm going to have to make quite a few changes to this kit. Let's take a look in my CAD model. Here's the new version of the vehicle in my CAD package. The first modification is the steering. I've moved it into the center of the vehicle and added this 2x4 plate so I can have twin bearings to support the steering axle. I've also increased the axle length so I can reach the steering wheel. Moving the steering to the center means I have to change to 8-tooth gears and take the rack pinion off center. This means I also have to move the rack off center by 1 stud. I've added a 1x8 beam to the chassis to strengthen the cargo bay area where I'll be sitting. This is tied through the original 1x8 beam and down to the main chassis with a 1x4 beam. Due to limitations on my printer size, I've split the 6x10 cargo bay plate in 2. I've arranged the plates in this order so there's some overlap on the 1x4 brick holding them together. This was my initial seat design, however I felt it was going to be a little too narrow. This is my redesigned version, which is wider and includes these side supports which should be more comfortable. Here I am sat in the car. As you can see, my head and shoulders are out through the top of the roll cage. It's very clown car-esque. I designed a version of the roll cage where I replaced the upright axles with longer versions. I don't think this looks too bad, but my head is still out the roof, so for now I'll just stick with the standard height. Let me know what you think in the comments. Can't wait to get it together, so let's get assembling. I have some printouts of my modifications so that I remember what to do when I'm building the chassis. I think I'm ready to go. Now, if you remember from my last build, which was the Lego car chassis 8860, which I made 5 times bigger, there was a huge amount of issues with the prints that came off the belt printer. And guess what? All of these parts have come off the belt printer. Well, at least all of the longer parts have anyway. Now, I hadn't spotted the problem before I started printing all of these parts. So all of these parts will suffer from the same issue, which is they'll be slightly undersized. The good news is that I've printed nearly all the parts on the belt printer. So they're all slightly undersized. So I'm hoping they're all going to line up. It looks about right. So fingers crossed, this is going to go together much easier than the last build, because at this scale, I just don't want to have to go through that again. It was miserable. Enough yabbering, let's get on with it. These are the 2 rear swinging arms, which I've just inserted the bearings into. So you probably saw me heating up the parts there, and that's just to push the PLA out the way a little bit where it's a little bit tight. Or where it's failed, the bridging has failed, you can just heat it up and push the bridging back in where it's drooped down a little bit. So I've added this plate on the top here to add strength to this section. That's usually not there. Now I should probably glue all this together, but I'm not going to do that yet because this might all have to change. So far the friction fit has actually been very good. So I had numerous problems with the belt printer when I was printing these parts. I can't even tell you how many failures I had. I upgraded the nozzle to a volcano nozzle so I could print faster, and this is all printed in Polymaker's Polysonic, so I could go faster, get higher flow rate through the nozzle. And this is all printed in a 1mm nozzle with 2 perimeters and I think about 10% infill. So it's fairly hefty, it feels pretty chunky. But the amount of failures I had, to be fair, it was given to me and it was second hand when it was given to me, and it is fairly old. So I upgraded it, then I had a bearing failure, I lost prints because of power cut, so I had to put a UPS on it. The Polysonic only comes in 1 kilo film, reels for red, so this is 3 parts. I can see the points where it started and stopped. So then I had to add a run out sensor, and that kept failing. So I was getting lots of false signals. It just took forever, and I have had a box of failed prints which have all gone off to be recycled, but it took way longer than it should have done. So it was particularly difficult, this job. This is the longest axle. It's a 12-way Technic axle comprising of 4 printed parts and a steel inner core. Oh, I've put those in the wrong place. I couldn't find a blacksmith drill bit big enough at 50mm. Well, I could find one, but it was very expensive, so I've gone with this cone cutter, or core cutter, sorry, which is pretty cheap and does the job. To start guessing what the weight's going to be, like we did on the car chassis. So don't forget 1,100 and I think 30 times the volume of the standard kit, and that's 200 grams. So what's the final weight going to be? I already know because I weighed all the parts separately just in case I couldn't lift it onto the scales. So start guessing in the comments. Now what have I done wrong? That piece should be in place because they're pinned. Come on, think! I'm not thinking. I just took this apart so that I could put this on. And I didn't put the pin in place. Here's one of my cheated parts. Rather than doing a 4 long and a 6 long, I just printed a 12 long all in one piece. No, it's a 10 long, sorry. 10 long all in one piece. I was missing holes in the long steering beams, so I'm adding them manually using a 3D printed drilling jig. Coming together. It's another cheated part. For ease of printing and strength, the steering arm is printed in 6 parts. The top and bottom pivot pins are bolted in place but not glued. This is so I can remove the steering arm from the vehicle without having to disassemble the steering arm support struts. The rear steering pin is a complete cheat. Again, for easy disassembly purposes, the top pin bolts in place while the lower axle half is glued in. The axle is recessed so at least it looks correct. To get the bearings into the steering arms, I'm using my bearing press with a 3D printed spacer insert on top of the bearing. Now hopefully you can see why I made these in parts. So the top pins unbolt, and that is so for assembly purposes you can simply push the pin through and bolt this back on. While I'm on the subject of bearings, let's take a close look at this rear swing arm. So I've got a bearing on each side of the rotation point, so that should hopefully try and keep it parallel. It's still probably going to want to twist though. And I've got twin bearings on the inside of the axle and an additional bearing on the outside here. And there's my suspension limit block, so the swing arm can't go up as far as the normal model. The other good thing about having these pins bolted onto the top through a weak point where there could be a shear, it's the same way that I've built all of these pins. They are glued, but they are also bolted through the middle, so you have a very strong connection through here, so that when you're bolting 2 parts together, there's a very good shear strength. Ooh, feels nice. Lovely. I've got to get those bolts in, which means I need to be able to get underneath. I think it's trestle time. I think I'm going to have to stop and get this on some trestles in order to continue. This doesn't collapse again. I have fixed the wheels on the table since the last catastrophe when it collapsed while building the car chassis. Yes! Gear change. Oh no. Right, well, that wasn't too bad. This is my special cheating part, which will have bearings in it for the steering and will look like 3 parts put together from the front. The pinion gear that does the steering is only supported from one side, from here, so by putting this on I can run bearings right the way through. I'm going mad. Put the hammer down. Where have I put the hammer? Somebody tell me, where did I put the hammer? Those pinions are indeed missing this top piece, my cheating piece. Nice. That looks beautiful. As per the original model, works nicely. Aha! The universal joint. Oh, that's not too bad. So I just ordered 3 more. Excuse me. Yeah, I just swallowed a fly. Anyway, what I was trying to say is I've run out of these slim 65 by 50 bearings which go in the front wheels here. So I can't fit the front wheels yet. But I've ordered 3 more. They should be here tomorrow. The steering wheel on the model obviously doesn't have this tyre on it. I've added that. And it's just a piece of neoprene rubber that I found on a website, and I've glued it together so it makes a nicer feel steering wheel. Like a glove. Oh, it's beautiful. I'm gonna be sat back here somewhere. Look at these bad boys. That's a suspension strut. Here are the parts that make up a suspension unit. First, I'm going to add this PTFE lined sleeve so the strut has a smooth surface to slide on, and it's held in place with this cap and 2 screws. A quick test fit of the polycarbonate strut. Yep, that's moving nice and freely. Now I can fit my spring and put the strut back in place. This spring is actually slightly too short. I couldn't get one the right size, so this suspension strut will have slightly less travel than it should do. Lastly, I fit this M10 cap head, which is the retaining bolt to stop the strut from coming out the end. I might add a spacer with the spring so then I get the full length of travel. There should still be enough travel in the spring to give me full compression. I purchased this spring from a website with limited data, so to calculate the force I used an online calculator. Using the wire diameter, coil diameter, free length and coil count, it gives me a force of 2.9 kilograms per millimeter. With 56 millimeters of travel in the spring, that equals 162 kilos of force at full compression. The suspension setup on the model is non-linear, so the suspension strut gets close to horizontal at full travel. This means the force to compress the swing arm suddenly drops off as the spring travel reduces. So in my version of the build, I'm going to reduce the maximum travel of the swing arm by using a 1x2 sloped brick. This prevents the suspension strut from fully bottoming out, and hopefully there will be enough force in the spring to return the swing arm to full extension. Oh, I'll tell you what, that is way too weak. I can tell you now. That's just going to collapse under my weight. And that's because of this non-linear relationship here. You've got a huge offset of lever on this spring, so it's not really moving much. Hey, that's pretty cool. It's only just going to take the weight of the car. I said it would take the weight of the car, but I think I'm wrong because, well, it does, but it'll be under compression. And when I sit on it, it's definitely going to bottom out. Well, I've gone online and ordered up some more springs that are nearly 3 times as powerful as these ones, but whether that's going to be enough, I'm not sure. Sometimes you have to put ear defenders on. All right, let's call it a day here, and I'll come back and carry on tomorrow. I need some special parts made up for this project, and for that I'm going to be using PCBWay, who are my sponsor. I'm going to use their 3D printing service to get some of these clear resin lenses made up. This translucent red is really beautiful, and I'm going to put them in a block like that, and they'll make the rear lights of the buggy. But the other service I'm going to be using is their CNC machining service. I'd like to be able to use these steel HTT5 pulleys because they have keyways, but it's quite hard to adapt them to fit on the O-drive motor. So I'm having a special part made up. This is in production right now by PCBWay, and that adapter is going to allow me to fit this keywayed steel pulley onto the O-drive. If you need some special parts made up, then why not go and check out PCBWay.com. They offer a range of services from PCB manufacture and assembly, 3D printing, CNC machining, sheet metal work, and I've used several of their services throughout my project. I'll leave a link in the description below. A slightly irritating thing about magnetic beds. So I put ears on this to keep the corners stuck down, but it's still lifted. I don't know whether you can see there or not. And it's not actually that it lifted off the bed because it was stuck perfectly in each corner. It's simply that the magnetic bed has peeled away because there's so much tension in the part. Pretty annoying. So on my front axle here, I'm going to add a thrust washer between the wheel and the faceplate of the steering arm. So it's just a bunch of needle rollers that run between these two faces, so you get very low friction between surfaces. And this is what I should have probably put between the rear swinging arm, so there's not plastic on plastic. You have these nice needle roller bearings. This has become dangerously rear heavy. So I think I'm going to rearrange things a bit here. It's now set on its suspension. Well, as you can see, certainly isn't going to support me. Right, I'm going to start building the roll cage. Where you have to ask yourself, is it in the right place? Because there's no way that's coming back off. Brutal. Got a roll cage, a flimsy one. I mean, it's never going to save your life, is it? In order to simplify printing and remove the need for support structure, I print these parts in 3 sections and then glue them together. So I probably need to figure out how to make these stronger because one of them's already cracked along the glue line. Having said that, these parts were always a weak point on the original Lego models, so maybe it's just meant to be. I've just remembered on my design, this bar here goes back here, so there's room for the seat. I've done it again. Oh, I'm just so excited to build it. I get carried away, and now I've got to take it apart again, and those never even needed to go on there. They're never going to come off, are they? It is epic. So I've just temporarily laid the seat in place, just so I can see where the back goes. I haven't actually fixed anything in yet. This is right in the way, so I think I'm going to have to move it back here like I had in my design in my CAD package. Turns out you don't really need much front suspension because there's so much twist in the chassis. I'm starting to doubt my axles' strength, both front and back, due to the weight, and my sanity. What in the hell have I done? So who noticed that I put one set of these this way around and one set of that way around? What's going on in my mind? Can't really get these off. It's so hard getting them on, it's just going to destroy these pieces. That means that A, 2 of them are going to be back to front and the others, which is really annoying. And B, you're going to have 2 of these just hanging around there for no reason. We'll call it styling. I know loads of people are going to be shouting that OCD is going to be through the roof with this. Sorry. It's just the way it is. Those are really annoying just being sat there, but let's just call it detail. If I get brave enough at some point, I might hammer them back to here. To get in and out, I was going to unpeg these front ones. That sort of works. Lift it up, get in, drop it back down again. I've been thinking about these springs, which is really annoying me. This is my temporary plan with the suspension spring. So what I've done, just taken that out, and I could put another spring inside of here. So then these two springs work in parallel. The problem is that this spring inside doesn't have enough room to compress to allow this all the way back. So I've lost a lot of the travel of this suspension strut. Now I don't need all the travel, but I do need at least more than this is going to give me. But it might work just to see if this is going to tighten up enough to take the weight of the car temporarily until I get some bigger springs on here. The new bearings have arrived, which means I can put the wheels on. And that's what I'm going to do, because I just want to see it on the floor on its wheels. The tyres are way too big to fit on any of my printers, so I've had to break them into quadrants, as you can see here. It's printed in Polymaker's high flow TPU material. Unfortunately, the bridging didn't work terribly well on the front, but the rest of the tyres come out very good. I've added a lip around the edge of the tyre which will locate into my PLA core and help hold the 4 tyre pieces in place. There is also a keyway that goes in the end to keep the tyre quarters aligned. The segments are then snapped together to form the tyre before it goes on the core. Here you can see the lips of the 2 quarters. These will slot into the corresponding lip on my PLA core. To stop the hub spinning in the tyres, I also added this keyway. I initially thought I would need to glue the tyres to the core, but it turns out the fit is really good. However, when I was printing the tyre segments, I had another idea to screw them to the core from the back, so I added these screw holes. I'd already printed the cores without holes, so I've made this drill jig which I can use to manually drill the required hole. Now I can add self-tapping screws through the core into the tyre to hold it all together. The core now drops into my tyre with the lips on the TPU aligning with the slots on the core, and this pulls the tyre pieces together. It's a tight fit and it does require some persuasion. Now all the self-tapping screws go in and that's the tyre complete. By adding a PLA core, I save a lot of TPU printing and I get a much more rigid tyre. The hubs are printed in 2 halves. The front half has 4 captive M6 square nuts inserted and is pushed down into the front of the tyre. The front half has the additional keyways to stop the hub rotating in the tyre. It's held in place with 4 M6 caphead bolts. It's a fairly hefty lump once it's all assembled. I thought it'd be fun to weigh it and it turns out at 4.6 kilograms. This wheel is loose on this axle, you can see that. So I think it's going to be better to reprint this axle tighter. Oh man, that looks cool. Oh man, that's heavy. Trestle's out. Okay. Right, and one wheel's down, other wheel's down. Okay. It's on the floor. You can't see it, but it is. Yay! Check it out. Looks pretty good from this angle. Don't really want to look around the back because the wheels are like, as predicted. I mean, obviously the suspension is collapsed. Look at just how bad that is. These beams I've just splayed right out, and yeah, that's in pretty poor shape. You can see how far apart these axles are. I could temporarily fix it by creating a solid axle through the back, and that would of course then stop that back end from sagging like that, which might be good enough for this version 1, and lose the independent suspension. I've got a plan to try and bring the independent suspension back, but it requires printing more parts and putting another swing arm in here. But for now I might just have to get an axle through there, a solid steel axle to hold that together. I don't think that even those stronger springs are going to be good enough for this suspension. I've got an axle stand underneath the chassis. It's taking the weight off those wheels. Dare I try and sit in it? I think I have to, don't I? Come on. Well, my head's out of the roof and out of shot by the looks of things. Oh man, I want to drive it now. So far away from being able to drive this yet though. It's just it's like the Naked Gun with the guy that was always had his head out of shot. Steering feels good. I thought it was going to feel quite heavy, but the front end of the car is obviously a lot lighter. Oh man, it's so temptingly close to being something that's insanely cool, but right now it's just I can't do much until this axle turns up, so I'm going to put the seat in and see how that works for me. It's really quite hard to get into. Well, I mean, I quite like the sloped brick. Feels like that's quite comfortable. Steering wheel's a good distance away. It's quite a wide stance. My legs really sort of want to be up on the dashboard, which is a little bit ridiculous, but it's actually more comfortable than kind of putting them out there. I can't believe how light that steering feels, which probably means that it's not going to steer very well, especially as the first iteration of this is going to have a solid rear axle, which means there's no differential on the back, which makes steering horrible. Not terribly. Oh gosh, don't fall off the axle stand. No, that's not going to work. Oh. It's not terrible, the seat, but it could be improved. The axle has arrived. Look at that beast. It's a 50mm with 2mm wall. It's a hollow tube axle for a go-kart. So the idea is that to hammer the axle through all the bearings, and it's going to join these two swinging arms together, which is going to give them loads of strength. But the first thing I'm going to do is take the wheels off and just try one bearing on it to see how tight the fit is. Oh, that's a lovely fit. Oh man, pleased about that. It's a nice fit. It's not over tight. I say that, I've only gone through one bearing so far. There's two. Oh, third bearing, tricky. Oh no, there's three. It's going. Now I hadn't planned on motorising the vehicle just yet. I was going to save that for video 2 because it's quite complicated. And this is a big build. I have printed this just in case, which is the same piece as the steering wheel, but with an HTD5 belted pulley built in. And I'm going to slide that onto the axle as the axle goes through, in the hope that if I do get time, I'll try and stick a motor on it just so I can see if it's going to be possible to motorise it. I'm sure it is, but it might take a bit more thought than this. I've modified this shaft clamp now to fit onto my drive wheel assembly. So I've added these 4 bolt holes here, which come through the whole assembly and bolt up at the back. And they're quite loose, so they're oversized holes, and that's to allow the shaft clamps to close down onto the shaft with the big screw here. And then once it's closed down and clamped on, I'll tighten those up. And if the friction fit doesn't work and the shaft still wants to rotate inside of this assembly, I've also added an M8 tapped hole here, which I can then drill a hole through and put a pin through the shaft to lock it to the drive shaft. Although it was easy getting the shaft through the first swing arm, it was proving difficult getting it through the next 3 bearings in the second swing arm. So I decided to move 2 of the bearings, 1 from each swing arm. Ideally, they need replacing with self-aligning bearings. Well, I've ended up spending a couple of days working on the electronics and code to make the motor work, as I'm just too impatient to see if this might actually work with a single 8325 motor. My biggest concern right now is that there is no physical brake, which means all my braking uses the motor to slow the wheels down using regenerative braking and by dumping energy into a braking resistor. My resistor consists of 2 500 watt 3 ohm resistors wired in parallel, giving me a total of 1.5 ohms. According to ChatGPT, this should be adequate for the braking I require, however, it still may need active cooling. For now, I've just bolted them to a large heatsink. I've made a control box with a power switch, a handbrake switch and a direction switch. There's also an 80 amp fuse inside. For the pedals, I'm using these low-cost sim racing pedals, which are perfect to get this up and running quickly. Eventually, I'd like to disguise these along with the control box to make them more Lego-esque. Fortunately, the new higher force springs have just arrived, so I'm going to install these whilst the car is still on the axle stands. I've removed the inner spring and I'll keep that in reserve just in case these new springs still aren't up to the job. The new axle uses a keyway to lock wheel rotation to the axle. I've made this small axle stub that is held in place with the keyway pins. My new rear wheel hubs also have the keyway slot in them and slide onto the axle over the keyway, holding everything in place. The wheel is held on with the same clamp. To secure my control box, I've made this special brick piece that I can attach with a few screws. Because it has the brick pattern, it means I can move it around and find a good spot for it. I've also printed a special piece for the pedals that will give me option for mounting position. I can route the control and power cables under the chassis. Now I can fit the second rear wheel. First of all, I need to make sure the swing arms are the correct distance apart, so I use this 1x8 plate to set the distance. It's ready to come off the axle stands, getting exciting, but I'm still not convinced it's going to support its weight with these new tougher springs, assuming I can even lift it. Let's have a go. Also slightly worrying is how much these rear chassis rails are flexing. Yes, still loads of sag on them. I think it's going to have the other springs in there. I've put the other springs back in, so there's 2 working in parallel now, and I'm ready to try it out. Oh, well, it's nice and bouncy. It has dropped down quite a lot. Oh, creaking and cracking. Oh man, look, that chassis twist is ridiculous. Anyway, I've got a battery in here. Fortune favours the bold. Handbrake off. Forward. No, nothing. Ew. Well, I may have just made the slowest vehicle in history. Actually, at 1 kilometre an hour, the Mantis that I made back in 2012 is still way slower. That's so disappointing. Let's see what the brake works like. The brake doesn't do much at all. I decided to plug in the laptop and investigate what was going on to see if I could tune things up a bit better. I also removed the roll cage for easy access. So I've got the brake and more torque forwards and backwards, but you can hear now that drive motor's just spinning on the belt. I can tighten up the belt tensioner slightly on the motor, but really it needs a metal pulley on the motor rather than a 3D printed one. If I run this up without me on it, it actually feels pretty good. But of course that's because there's a lot less weight on here, which tells me it needs 2 motors or a bigger motor. There's a ton of stuff I clearly need to do to get this working properly. The belt's slipping, can't brake very well, it needs a physical brake. Getting it driving is one thing, but there's some bigger issues going on here. There's a very large gap opened up just here, which is where the chassis member here runs back and supports the seat, and I've got my additional one here running through and they're pinned together. And what's happened is it's doing that. And that's probably because of the amount of force on these springs. Even though I'm sat on the seat pushing the springs down, it's wanting to do this with the chassis. And I think that this is separated whilst I'm getting on the vehicle. So when I'm stood here, for example, those springs are simply pushing up. There's no weight on the back end to keep them down. So it's when I'm getting on and off that this is wanting to separate, and that makes more sense. Right now, I've just got to get it to this show and fall next, so I'm not going to worry about it next, but it does mean I probably can't take this much further as far as driving is concerned, because I don't want these two parts to snap. Next challenge is to get this out of the studio and down to the garage. Oh man, that's heavy. Heavier than I thought it was going to be. Oh. And really hard to turn because I've got no differential. Garage, next stop. Well, after a lot of back and forth on the gravel, I started to feel like Austin Powers, and it just wasn't going to shift with my weight on it. For those playing Guess the Weight game, the final weight came out at 102 kilos, that's 224 pounds. While it's on this smooth floor, I'm going to try one more time to drive it. Basically, it couldn't even handle a little bit of gravel with me on it. It's woefully underpowered. I'm steering and it's going straight forwards. Yeah. So without that differential, basically the steering is non-existent, as are the brakes and acceleration. Tiny bit of steering, brakes, a little bit. Brake. Brake works better than the accelerator at the moment. I think it's fair to say it needs a lot more power, or bigger motors, or two motors. But when it's done, it's going to be a lot of fun. You may have noticed that the suspension is sitting much better now. The back's higher up, the swing arm's lower down, and it's more like the original model. I've achieved this by moving the suspension strut back one pin on the swing arm, so you get better mechanical advantage. I've actually even gone back to my softer spring, and there's still plenty of support here for me and the weight of the vehicle. The only compromise is losing some of the travel in the swing arm. But that doesn't bother me so much. As long as it supports the weight of the vehicle and the driver, that's the main objective. And there's still plenty of travel left. In order to get the car turning better, I'm going to remove one of the keyways on one of the rear wheels. This effectively turns the car into one-wheel drive, and is a temporary measure until I can sort out a differential drive. To do this, I've had to add this threaded bar through the axle in order to retain the opposite axle stub that was previously held in place with the keyway. The wheel now spins on the axle, which will allow the car to turn better. There should be a thrust washer between the wheel and the nut to prevent the nut from undoing. Time to give it another test run. Oh, that turns better, but of course it wants to turn left really easily now, but probably won't want to turn right. A left turn is easier because the right-hand wheel is driven, which is the outside wheel on a left-hand turn. This makes the car a bit of a Zoolander. It's not an ambi-turner. got to find an easier way to get in and out of this thing. Clearly the drivetrain needs a lot of work, but that's going to have to wait because I need to get to Formnext in Germany. Obviously, I'm not going to be driving that all the way without a number plate. Next stop, Frankfurt. See you on the Polymaker stand. Hope I've charged the batteries.